In section 6.2 in the first half, we're going to look at multiplying radical expressions. So the first main idea of this is that if a and b are both being taken to the nth root, then I can simplify that as the nth root of a times b, so basically just multiplying everything under the radical. For example, could I simplify something like the cubed root of 6 times the square root of 2? Since they're being taken to different roots, no, I can't. On the other hand, I could simplify something like the cubed root of negative 4 times the cubed root of 2. I'm going to multiply negative 4 and 2 under the radical to leave this as the cubed root of negative 8. From there, I can let my calculator do the rest, and my final answer is negative 2. The next main idea of this section is that if the nth root of a has a perfect nth power amongst its factors, you can reduce it or move it out of the radical. So this is kind of getting at the idea where when we were reducing square roots and we were looking for perfect square factors among that number to kind of move it out of the radical, this is kind of what we're getting at here. Before we do that, a quick tip that we could look at here is prime factorization. So since we're moving beyond just taking square roots, now we're going to look at cubic roots and taking fourth roots, it's hard to kind of memorize perfect cubes along with perfect squares and even numbers higher than that. So one way we can get around this is by doing prime factorization. So for example, if I want to find the cubic root of 24, I need to think about perfect cubes that go into 24. So how I could do this is I'm going to start with 24, and I'm going to keep dividing this out and finding factors until I'm left with all prime numbers. So starting with 24, I'm going to break this down to 2 and 12. What's nice about prime factorization is that I could start with any factors, so I could break this off into 3 and 8, 6 and 4. It doesn't matter. As long as I'm picking the correct factors, I'm going to end up with the same result. 2 and 12 breakdown, 2 stops because 2 is a prime number. Starting with 12, I'm going to break that down to 3 and 4. Finally, 4 will break down to 2 and 2. And I'm left with the list of all prime numbers. So I can rewrite 24 as 2 times 2 times 2 times 3, or 2 cubed times 3. So I found a perfect cube within 24. I'm going to put that back under the radical as the cube root of 2 cubed times 3. I'm going to split that off to see how it breaks down. The cubed root of 2 cubed will cancel each other out, so my final answer is 2 times the cubed root of 3. Next, I'm going to look at simplifying a radical expression, so basically the same thing, but with variables in it. So first I want to simplify the cube root of 54 times x to the 5th power. I'm going to start by doing a prime factorization of 54. So I'm going to take 54, I'm going to break it down, I'm going to break both of those down again, and here I'm left with 54 as 3 times 3 times 3 times 2, or 3 cubed times 2. I'm going to rewrite that back in the radical, and from there, dealing with that x to the 5th power, I'm just going to break it off. If I'm trying to take a cubic root, I'm going to pull 3 x's out of x to the 5th and rewrite it as x cubed times x squared. So now, taking the cubed root of this, I'm looking at perfect cubes within the radical, which are 3 cubed and x cubed, so I can move those out of the radical and kind of cancel it out. So my final answer here is 3x times the cubed root of 2x squared. The last problem we're going to look at is simplifying 2 radicals multiplied together. So here I want to simplify the square root of 72x cubed times y squared times 10xy cubed. So since they're both being taken to the square root, I can multiply everything under the radical and rewrite this as the square root of 720 times x to the 4th times y to the 5th. Since I'm taking the square root, if you can think of a perfect square that goes into 720, you can skip the prime factorization step. I'm just going to go ahead and show how you can do this even for a square root. So for 720, I'm going to break it down. I'm going to keep breaking it down again until I'm left with all prime numbers. So I can rewrite 720 as 2 to the 4th times 3 squared times 5. Putting that under the radical, I'm going to move 2 to the 4th power and 3 squared outside of it to begin with. The square root of 2 to the 4th power is 4. The square root of 3 squared is 3. From there, 4 times 3 simplifies to 12. and I'm left with 5x to the 4th times y to the 5th under the square root. So my last thing to do is to kind of deal with this y to the 5th power so I can get it to evenly break down if I'm like dividing that radical by 2. So I'm going to rewrite y to the 5th as y to the 4th times y. The whole reason I did that is that from there, I'm going to divide x to the 4th and y to the 4th by 2 and move it out of the radical, and I'm going to be left with 12x squared times y squared times the square root of 5y.